All right, so let's talk about the security of stream ciphers, most importantly, the randomness of the key stream, and then I will talk about some standards that we have. So asynchronous stream cipher attempts to capture the spirit of one-time pad by using a short key that generates the key stream, which appears to be random. Since it is generated from a shorter sequence, we cannot say that the key stream is now random. Instead, we will call it pseudo-random. Much of the work in the field of stream ciphers is deciding what constitutes a pseudo-random sequence. In this context, key stream generator stream ciphers are evaluated by means of the quality of the key stream it produces. Okay, so let's look at the quality of a key stream. A key stream generator stream cipher is as secure as its output is closer to be random. This concept can be understood in two ways. One, is there some imbalance to the way the sequence is generated that allows the cryptanalyst to guess the next bit with some probability better than that of random guessing? So generally, I mean, if it is random, a bit can be generated as 0 with probability 1/2 and 1 with probability 1/2. But by looking at the previously generated bits, if you can get a little bit more advantage for guessing the next bit, then the attacker can use this. So this is related to appearance, right? Next thing is it hard to reproduce the sequence? So this is related with the inherent complexity of the sequence. Okay, so there are two different ways of looking at it. So if we look at the first question by the appearance, we can measure its appearance. For instance, we can look at its period. So if it is short, we will say that, okay, it repeats itself in a short period, then we cannot use it as a key stream. But if the period is long, and almost in all of these stream ciphers that are created so far, the period is generally large, like at least 2 to the 100 and that kind of stuff. So by looking at the appearance, in other words, you give me zeros and ones, and I want to decide if it is random or not. So there are many statistical tests that you can apply and see if it looks random. Okay? So NIST also has a randomness suite, but there are also others. But if you look at the question in the second way, where we look at the complexity, the inherent complexity, there are methods like checking linear complexity, max order complexity, lamp-as-if complexity. So, okay, let me briefly summarize what the linear complexity is. So you give me, for instance, 100-bit zeros and ones. I want to know what is the shortest LFSR that can generate this sequence. So linear complexity actually measures that. And there's an algorithm called Berlekamp-Masse that will give you the shortest LFSR that can generate the sequence that you gave as the input to the algorithm. Okay. So let's look at some of the standards and some of the stream ciphers that we use in practice. So in the past, generally, stream ciphers were faster than block ciphers until lightweight block cipher designs came off. Okay, this is why in the past, as you can see, we use stream ciphers for data in transit. So in GSM, we used A51 for wired equivalent privacy. In our modems at home, we use RC4, and Bluetooth, we use E0. So these two are broken. So nowadays we are using A53, which is also called Kasumi, a block cipher. And in Wi-Fi, we use VPA or VPA2 protocols where we use AES. Okay, but even although these are outdated, a lot of people are still use A51 because it is not up to you, your GSM operator actually chooses. If you are using an old phone, for instance, then you have to use it. Or the person you are calling uses a very old mobile phone, then you have to use this algorithm. Okay, so. Like AES competition, academicians said that we don't have good stream ciphers. Let's increase our knowledge in this area. So for this reason, they created a competition called eStream. So it started in 2004, had 34 candidates algorithm, and 7 of them are included in the final portfolio in 2008. So out of the 7, 3 of them were suggested for hardware like Grain, Mickey, and Trivium. And software, we had 4 candidates, 4 finalists, let's say, HC128, Rabbit, Salsa 2012, and Sosemano. But out of these, Trivium became ISO lightweight stream cipher standard, in 2012, and Salsa, a modification of it called Cha-Cha, is currently used in TLS 1.3. Okay. So NIST doesn't have any Steam Cipher standards, by the way. This is why I'm not showing you any NIST standard, but ISO standards, we have many. So in this ISO standard, it describes both pseudo-random number generators for producing key stream and output functions to combine a key stream with plain text. So for the output functions, you have XOR operation and that kind of algorithms. But for key stream generators, there are 5 stream ciphers that are ISO standard. But I don't know if they are used in practice. I mean, since this is ISO standard, you might say that probably somebody using it, but I never seen any real life, real world example. So I don't know if any of them are popular or not. As I said, Trivium become a lightweight stream cipher standard. So in 2012, so this is revised in 2022, I guess. So these 2 algorithms, Enokoro and Trivium, are still lightweight standards. But Trivium uses 80-bit secret key. So we already seen that this is not secure. And Enokoro supports 2 key sizes, 80 and 120. Again, this is not enough for today's technology. So Enokoro with this secret key bits can be used in practice.